Look at a black hole, and your eye is drawn to the violent swirl of the accretion disk. But the most significant physics problem lies hidden at the absolute center. Classical physics insists that at the core of a black hole sits a singularity. This is defined as a point with zero volume but infinite density. We measure this core using the Ricci scalar curvature equation. It calculates exact space-time curvature based on mass and radial distance, variable r. Approaching the center, that distance drops to zero. Dividing by zero forces curvature to infinity, completely breaking general relativity. This infinite density point also crashes quantum mechanics. If a zero-volume point swallows matter, all the quantum information encoded in that matter appears to be permanently destroyed, violating a core rule of the universe. The math provides an error code. The singularity is almost certainly not a real physical object, but a mathematical red flag proving that general relativity cannot account for the extreme density of the core. Nathaniel Faxon-Sharir proposes a solution in his book My Dear Universe. He outlines a framework called Black Hole Ringularity Theory, or BHRT. BHRT suggests we have been visualizing the core incorrectly. Instead of a static dot of infinite density, the core is a dynamic, shape-shifting topological structure. By replacing a rigid mathematical point with a flexible, evolving shape, BHRT removes the infinite density paradox. The math functions cleanly, allowing general relativity and quantum mechanics to coexist. This is a 3D model of the initial core shape under BHRT. When a black hole gains enough mass and reaches a spin rate greater than 0.5, extreme frame dragging stretches the core into this stable, donut-shaped torus. In astrophysics, this is known as a ringularity. But black holes continuously swallow matter. As mass accretion increases, the ringularity becomes unstable. It twists, transitioning into a single-sided Möbius strip. Because the Möbius phase creates a non-oriental, single-sided surface, quantum information that was previously trapped inside the black hole is temporarily able to leak out into the universe. Eventually, the core stabilizes again through a final evolutionary transition. The strip folds back through itself, creating a Klein bottle, a closed geometry with no distinction between inside and outside. Through this specific sequence of shape-shifting, the black hole creates a physical mechanism where information is both held and safely released. The quantum information loss paradox is resolved. So, what actually forces a supermassive object to twist itself into a Möbius strip? The engine driving these transformations is extreme magnetic field dynamics. Earth has a simple two-pole magnetic field. A black hole core, however, can possess highly complex multi-pole configurations, housing quadrupole and even octupole magnetic fields overlapping at once. The surrounding accretion disk is turbulent. It dumps immense, uneven angular momentum directly into the black hole. This turbulence forces those complex magnetic fields to spontaneously reverse polarity in an event called a pole flip. A pole flip releases devastating energetic stress. That energy physically tears at the geometric fabric of the ringularity, forcing it to undergo its topological transformations. These pole flips and topology changes do not happen quietly. BHRT predicts they blast the universe with measurable physical evidence. The first signature is in gravity itself. During a topology change, the black hole emits gravitational waves that undergo sudden, highly specific frequency shifts and amplitude variations. The second signature is light. The violent shifting of the core disrupts the massive accretion disk overhead, triggering intense, short-duration gamma-ray bursts. This line graph displays Hawking radiation temperature over time under the BHRT framework. Notice the sudden surge. During a phase shift, the emission of exotic particles increases by a factor of 10 to 100. By synchronizing these gravity, light, and radiation signals, BHRT provides a unique, testable set of markers. Astronomers have a specific blueprint to verify the theory through observation. We already have the hardware to detect these specific fluctuations, and a global network of advanced facilities is actively scanning the sky. Observatories like LIGO are continuously listening to the fabric of spacetime, specifically searching for the high-frequency gravitational bursts caused by stellar mass pole flips. Above the atmosphere, the Hubble Space Telescope is monitoring volatile accretion disks, looking for the optical and X-ray variability that indicates a shifting core, and sprawling radio arrays, like the VLA, sweep the heavens for the fast radio bursts tied directly to ringularity instability. Black holes function as the most complex, shape-shifting topological engines in the universe. If you want to keep exploring the deep physics of the universe with us, make sure to like this video and subscribe to the channel. Thanks for watching.